Welcome back, everybody, for another deep dive. This time into something that sounds like it's straight out of like a Dan Brown novel.
Oh, yeah.
The Golden Ratio.
I was going to say the Da Vinci Code. Yeah.
Exactly.
Yeah.
But trust me, when we get into this, it's even cooler than like a thriller novel.
Yeah.
Because this is like actual math or like underlying principles of the universe.
Yeah. What I think is so cool about it is that it's like, it's not just this like abstract mathematical idea.
Yeah.
It's like, we're going to see, it's actually like woven into the fabric of the world around us.
Okay. So I am ready to have my mind blown. But
Yeah.
before we do that,
Yeah.
let's just like get on the same page.
Totally.
When we say golden ratio, what are we even talking about?
Right. So at its base level, it is a mathematical ratio. It's 1.618, represented by the Greek letter phi. And essentially, it's this idea that you can divide a line into two parts,
Okay.
such that the longer part divided by the smaller part is equal to the whole length divided by the longer part. So it's this like beautiful proportion.
Okay, so that's still like my brain is still trying to catch up with
Yeah.
that. I'm not gonna lie.
But it sounds a little less Dan Brown novel.
Oh,
A
well,
little more
a little more mathy than I thought.
math class.
Yeah,
Okay.
totally.
But this is something that like even Euclid was fascinated by.
Oh yeah, going way back.
Okay.
Euclid in his Elements referred to it as dividing a line in extreme and mean ratio,
Okay.
which I think it's a much less catchy title.
Yeah. Not as good.
Golden ratio is much better. But yeah, he wasn't just interested in it as a way to divide lines.
Okay.
He was interested in it because it also deals with area.
Okay.
So it's like embedded in the very shapes themselves.
Okay, so we've got proportions, we've got areas, we've got Euclid.
Yeah.
Where does the golden come in?
Right.
Like, why is the seed? Why is it golden? Why is it not just like the silver ratio or the bronze ratio?
Right. Like, what's so special about this number?
Yeah, well, this is where I think things get really interesting, is that it's not just some arbitrary number.
Yeah.
It actually comes up in places that you would not expect, and it has these like unique mathematical properties.
Okay.
And one of the most fascinating, I think, is its relationship to the Pythagorean theorem.
Okay.
You know,
The a squared plus b squared.
exactly, a squared plus b squared equals c squared,
Yes.
right? So that's about right triangles.
Yeah.
And it turns out that any right triangle can be inscribed inside of a semicircle.
Okay.
And where that circle intersects, the longest side of the triangle divides that side in the golden ratio.
No way.
Yes.
So every right triangle has the golden ratio kind of like
Hidden inside of it?
embedded inside of it.
Yeah.
That's kind of wild.
Yeah, and this is, like I said, this is just the tip of the iceberg.
Okay.
This is,
Just getting started.
yeah, we're just getting started. We're going to see it pop up more.
Okay.
Yeah, and a really amazing example is if we look at the pentagon.
You mean just like the shape?
Yeah, the
Like a
shape.
stop sign?
Exactly. The
Right.
pentagon is like the golden ratios like playground.
Oh.
It's just chock full of golden ratios.
So is it like
it's amazing.
if you draw a pentagon and then connect like opposite points or something?
Well, every line segment within a pentagon when compared
Oh.
to another one,
Okay.
it's in the golden ratio.
Whoa.
Yeah. So like imagine like these perfectly proportioned like nesting dolls
Okay.
of pentagons inside of each other, all related by the golden ratio.
So they're all golden ratioing each other.
They're all golden ratioing each other. It's amazing. And that's actually a really beautiful example of what's called a fractal, because it's this repeating pattern that
at different scales.
at different scales, it's the same thing. And what I think is so cool about the golden ratio is that it helps us to see beyond the surface of things, to see these like hidden patterns and connections that are all around us.
I'm intrigued.
Yeah.
Let's keep going. Okay, so we found the golden ratio hiding in like the DNA of geometry.
Right.
But our sources are saying that it goes way beyond just shapes,
Oh, yeah.
right?
It's everywhere.
Like where else?
So think about all those spirals you see in nature,
Okay.
seashells,
Mm-hmm.
the way sunflower seeds are arranged,
Okay.
even the shape of galaxies.
Hold on. Are we saying that like math created the galaxy?
No. It's not that the math like created it. I think it's more that like
Okay.
the golden ratio is like this recurring theme
Okay.
in the way that things grow and organize themselves.
Okay, so it's not like there's literally little golden rectangles
No.
like floating around in space.
It's not like a cookie cutter.
Okay.
It's more like a principle.
Okay, give me an example, like something I could like actually notice.
Okay, so have you ever like looked at a plant
Yeah.
and noticed like how the leaves are never like directly above each other?
Oh, they're like offset a little bit.
Exactly.
Okay.
They're offset. And you know what that angle of offset is? Often close to
No way.
137.5 degrees.
Ooh.
The golden angle.
There's a golden angle now, too.
The golden angle? This is like, it's not a sale at the geometry store, but...
Oh, my gosh.
Okay.
It's pretty cool.
So wait, what is the golden angle like?
So the golden angle is derived from the golden ratio.
Okay.
And it just so happens to be the angle that optimizes packing.
Okay.
So it ensures that the maximum amount of sunlight can reach each leaf on a stem.
Wow. So it's like efficient.
It's efficient.
That's so cool.
It's not just about aesthetics. It's about, like, survival.
The golden ratio is like a Swiss Army knife
I like
of, like, the universe.
Yeah.
Okay.
And it goes even deeper.
Okay.
Because our sources even link the golden ratio to the Fibonacci sequence.
Okay, that one I've heard of, but I don't totally remember.
Okay, so the Fibonacci sequence is that series of numbers where each number
is the sum of the two before it.
Oh, right.
So it starts with 0 and 1.
Yeah.
And then it goes 0, 1, 1, 2, 3, 5, 8.
Right. Like each number is
13 and so on.
Yeah. Okay, I remember now.
So how do we link that to the golden ratio?
Yeah, they seem very different.
Yeah, on the surface, very different.
Okay.
But here's the cool part. As you go further and further along the Fibonacci sequence, the ratio between consecutive numbers gets closer and closer to...
Don't tell me.
The golden ratio.
The golden ratio? No way.
Yes.
So like 13 divided by 8 is like 1 point something?
It's like 1.6.
Which is basically
the
golden ratio?
Exactly. And it gets closer and closer the further you go.
Exactly.
Okay.
It's like it's honing in on something.
That's so cool.
Yeah. And so what's really wild is we find these Fibonacci numbers. And by extension, like little hints of the golden ratio all throughout nature.
Like what else? So we've got the arrangement of branches on trees. The arrangement of petals on flowers. The spirals of our DNA.
No way.
It's all like interwoven with this.
Oh my gosh.
This mathematical dance.
I know we're not supposed to like anthropomorphize.
Yeah.
But it's like the universe said, I like this. I'm going to use this one.
Right. So this is my favorite.
Like how, is it intentional or is it just like a happy accident?
Right. That is the $1,000,000 question, isn't it?
Yeah.
I think, you know, some people would say like, oh, it's evidence of like a deeper cosmic order, like a blueprint for beauty and efficiency.
Right.
That transcends like all these different disciplines.
Okay.
But then other people would say, no, it's just math.
Right.
Like, it's just a consequence of...
It's got to be math somewhere.
Yeah, it's just math. And we happen to find it pleasing.
Okay.
Because we're humans.
So no definitive answers.
I don't have a definitive answer for you.
Not a definitive answer.
I know, it's kind of...
Come on, universe.
Frustrating, but in a way, I think it's kind of beautiful, right? Yeah. Because every time we see like a spiral in a seashell or a sunflower or whatever, it's like we're watching this mystery unfold.
Oh, I like that.
Yeah, and it's a question that people have been asking for centuries.
Yeah.
And we're still asking it today.
That is pretty cool.
Yeah.
Okay, well, I'm convinced I'm going to go for a walk after this and just like look for golden ratios everywhere.
You should.
See if I can spot them.
And it doesn't stop with nature.
Oh, really?
No, look at art.
Okay.
Look at architecture. Look at music.
Okay.
Ancient Greek temples, Renaissance paintings, Debussy's compositions.
Oh.
All of them.
There's golden ratio in music.
They have whispers of the golden ratio in them.
No way. Okay. I need to go investigate my record collection.
You do?
This is amazing.
Keep your eyes peeled.
Oh my gosh. Well, thank you so much for being our guide on this.
Oh, it's my pleasure.
Deep dive.
It's been fun.
This has been incredible.
So glad you enjoyed it.
I feel like I see the world differently now.
That's what it's all about.
All right, everybody, go listen to some music. Look for the golden ratio. We'll catch you next time.